So we have, from past experience, we know how to make the total population. That's exactly the same as before. It does give us our house size. We're going to split 74 stores into 8 cities around the world. So that's our house size is 74. We know how to find our natural divisor. That's exactly the same as before. And we know how to do our natural quotas. Those are exactly the same as before. So we'll get those in. Take a moment. Get the populations. Get the total, house size, natural divisor, natural quotas. Populations, total, house size, natural divisor, natural quotas. Here's where things change. Every single time, our rounding cutoff changes. It depends upon how many seats you, or whatever your natural quota is, and whatever the number of seats you could possibly have. And so our rounding cutoff switches potentially for every single quota that we have. The first state that we have here, we've got 16.5. Well, that could round up to 17, or that could round down to 16. So I look at 16.54. That could round up to 17. That could round down to 16. So we create the rounding cutoff specifically for that population. Now we could go through and just type in square root 17 times 16, but as soon as we change those numbers, we'd have to do this again. So what we want to do, we're going to take the square root of 16 times 17, but we need to generalize it. For the next one, we could be 10.4. Well, 10.42 could go up to 11 or down to 10. We're going to need the square root of 10 times 11. Every single time, we're going to be taking the square root. So I'm going to create a formula here. Every single time, we are taking the square root. And why is my formula not showing up? Well, how do I take the square? If I just start typing square root, we get something that shows up, SQRT, squirt. So we're going to take the square root of, well, looking at the example, we've got 16 times 17. Where do those values come from? Well, 16 is our natural quota rounded down. 17 is our natural quota rounded up. So, do we know any formulas that say round down this number? Yes, we do. Well, round down, I'm going to take the square root of our natural quota rounded down, multiplied, make certain you put in the asterisk. It does not like just the formulas touching. So, round down multiplied by that number rounded up. So I've got square root, whatever number that is rounded down, multiplied by whatever that number is rounded up. This gets our rounding cutoff for this specific value. It's not always 0.5. It's not always the integer. It's not always rounded up. Changes every single time. Once I have that, I will take my little blue bubble, autofill all the way down. Yep. multiplication. I've got an asterisk in there. Multiply. Natural quota. So formula is written up here as well. We can see that. Looking at these numbers, that very first one, we've got a natural quota of 16.54. We've got a rounding cutoff. This is the break. Above this, we round up. Below this, we round down. We've got 16.49. So that first state, how many seats do they receive? 17. We're going to get 17. The next state, natural quota is 10.42. Rounding cutoff is 10.48. 10.42, 10.48. How many seats are they going to receive? They're going to get 10. How do you decide that? 10.42? Do you have a natural divisor of 1.96? Do you have a total of 145, 113? So check the numbers, but also is your sum going all the way down, all 8 of those cells? So we've got everything. Check your numbers. So we want to think about, now we could look through every single number and make the comparison. All right, they get 17, they get 10, 9.79, 9.4, 10. We could go through every single one and make the decision, or we could explain to the spreadsheet what we're doing in our heads so it does it for us. How do we make that decision? Question? So how do we make that decision? I'm going into Hill-Huntington initial allocation. What we're thinking about, if a number is greater than the rounding cutoff, you're going to round up. If a number is less than the rounding cutoff, we round down. So this idea of thinking, how do we make that decision? If this happens, then we go with this. We're going back to a conditional statement, back to geometry when you have if-then statements. Excel or the spreadsheet can do that. So if, we're going to create a logical statement. We're going to make a comparison. So I'm going to equals if. And the way this works for you, I believe it shows up where it gives you the guidelines of this needs to go here, this needs to go here, so forth. So under E2, start off. If, what are we comparing? Well, we're going to compare the natural quota to the rounding cutoff. So I'm testing whether the natural quota is greater than the rounding cutoff. So I will put in if C2 is greater than D2, what do we do if is? Put comma. So the way this works out is we take what are we comparing? What happens if it's true? Then what happens if it's false? So if the quota is greater than the rounding cutoff, we're going to round up. So we tell the calculator, make the comparison. If C2 is greater than D2, we're going to round up that number. Comma, what do we do if it's not greater than? We're going to round down. We have this conditional statement, this if-then statement. If, what are we comparing? This is what happens if it's true. This is what happens if it's false. Fill in the rest. Should be one line. Thinking that back in the 70s when Microsoft, or the early 80s, back in the 70s, 80s, when they were working with spreadsheets, George Lucas just tapped a bunch of times and named his robots. 1977. We got C2D2, C3PO, R2D2. If you want to take him out and fight him for that one, I'm going to pretend I don't see anything. Star Trek was back in the 60s. Once we have that, don't actually go out and fight him. That's not nice. No touching. Okay, you can be at his house. That's creepy, but okay. But he's. I'm gonna take that, copy it all the way down. We've got all the rounding. So checking, 16.5, 16.4, rounds up. 10.4, 10.48, rounds down. 9.7, 9.4, rounds up. 9.6, 9.4, rounds up. What do we do with those numbers? We need the sum. So down to the bottom, I'll get the sum of our values. And at this point, we get back into the idea of what we need to do with a divisor method. We have a divisor of 1.961. We have 76 seats right now. We need 74 seats. So we've got to change our divisor. So here's where we have a divisor method. This is the guess and check part, or the logically thinking your way through things. If our divisor gives us 76 seats and we need fewer, we're going to pick a new number. Do I pick a number that is greater than 1.96 or less than 1.96? Greater. So we need fewer seats, divisor goes up. We need more seats, divisor goes down. Pick a number greater than 1.96. 2 is a great easy number just to start off. If you want to put in 3 on yours. Let's see what happens. I'm just going to put in 2. Hill-Huntington divisor. Now, ideally, that's going to go and calculate the rest of the spreadsheet for us. Oh, we've got to write some formulas for that. Modified quota. We've done that before. That. So we get our modified quota. We'll copy that down. We see that numbers have changed. Rounding cutoff. We're going to mimic just what we did before for the rounding cutoff. So our rounding cutoff, this is going to be F, E, F, G. We take that new modified quota, create the geometric mean based upon what that could be. So G2 is going to be square root, so round up, F2 multiplied by round down, or round down multiplied by round up. That. Calculate a new rounding cutoff because our numbers can change. And then we'll have the final allocation. So once we have that rounding cutoff, we'll make the same kind of comparison as we did before. I'll write that up there. And I will copy those down. Any formulas we need to see? How are we doing? Find the sum at the end. We see when a divisor, if I put in 2, 72 seats. How are we doing? Problems, spreadsheet problems, difficulties, anything that we need to catch? You need me to go back anywhere? So that is that's the rounding cutoff there right now. Final allocation is this right here. We've got through things. For this example, the natural divisor 1.96 gives us 76 seats. Too many. We tried 2 as we programmed it along the way. 2 gives us 72 seats. Too few. So here's the way I think. 1.9 is too many. 2 is too few. We need something right in the middle to get us 74. So pick a number right in the middle of 1.96 and 2. 1.98. Here, by having the spreadsheet, if everything's in place, all we need to do is go tweak a number, change one thing. We do 1.98. In this case, it works out. We get our 74. So there's our divisor. There's our allocation. We can see how it's compared to those originally. That first state ended up going down 1. That stayed the same, stayed the same, stayed the same. The 5th state lost 1 and everybody else stayed the same. So we had a way of doing this. The value behind the spreadsheet is now anytime we do Hill-Huntington, we just need to put in the numbers and figure out what the divisor is going to be. It does all of the number crunching for us. That frees us up to think about how we're going to think about things and other patterns that show up along the way. Looking for ideal properties. What makes a good method? What makes something not so good? I do want you to still know, how do they round? So if I ask you, how does Jefferson round? You need to know Jefferson rounds down. Webster, you need to know rounds at 0.5. Hill-Huntington, geometric mean. So if I give you just one set number and say, what's the geometric mean? You can still find that. Or you can round things appropriately. We need to see any of the other formulas in there. How does that look?